Alright, so we are going to be talking about Taylor and Maclaurin polynomials. And we're actually going to start with Maclaurin's because they're centered at 0. So what is this thing going to look like, you wonder? Well, actually, let's go to this line. Because this, my eraser's not working. Okay, just don't make any mistakes because I can't erase anything today. Your Maclaurins are going to be centered at 0. So that means our C value is equal to 0 with a Maclaurin series. So what does this look like? Well, we're going to have our original function evaluated at 0. Then we're going to need to know what our first derivative is evaluated at 0. Technically, this guy would be over 1 factorial, but 1 factorial is just 1. Plus, now look, we're taking a second derivative evaluated at 0 over 2 factorial, and notice I also have an x squared. Then I go on to my third derivative evaluated at 0. Notice third derivative, 3 factorial, 3 cubed, or x cubed, so raised to the third. If I had to go on to the fourth, can you guess what the fourth term would look like? It would be the fourth derivative evaluated at 0 over 4 factorial with x to the fourth power. So the general form of that is this guy right here. So it's whatever degree you're at, whatever derivative, over that number of derivative factorial times x to that same power. And again, Maclaurins are all centered at 0. When we get to Taylor polynomials, then we got to worry about this line right above this guy, where if we have a C value that's not 0, then it just makes things a little bit more, but nothing major. And we'll do that tomorrow. So we have been given f of x is equal to e to the 3x with a degree of 4. So that means they want us to go out those 4 terms. So go to the fourth derivative. So the first thing I like to do with these is I like to just go ahead and evaluate. Remember, we are going to evaluate this at 0 because it's a Maclaurin. So that means I need to evaluate at 0. So I like to give myself a little table over here so I have some room. So here I'm going to take the derivative, and then I'm going to evaluate that derivative at x equals 0. All right, so let's start off with the first guy. So we have e to the 3x. So now if I evaluate that at 0, we have e to the 3 times 0, which is really just e to the 0, which, anything to the 0 power is 1. And I think I will just do this so that I have my numbers all nice and clear to me. All right, now this was f of 0. Now let's go to f prime. So remember your e to the u, it's u prime e to the u. So I'm going to have 3 e to the 3x. So now when I evaluate that, 3 e to the 3 times 0, we already know this portion is going to give us a 1, so this is going to be equal to 3. Then we'll go to our second derivative. Right, so we're going to have 9 e to the 3x. So we plug our 0 in, and we're going to end up with a 9. Going to that third derivative, oops, my program is not behaving well, so I can't scroll. I'm going to have to write smaller. All right, so now we're going to have 27 e to the 3x. So when I go to evaluate that, we're going to have 27. Oh, now my thing's finally catching up. And remember, we had to go to the fourth derivative. So now we're going to have 3 times that 27. Let me do that really quick. So 3 times 27 is my 81 e to the 3x. And so when I go to evaluate this, I get 81. All right, so now we're actually ready to make our polynomial. So our polynomial to the 4th degree, our variable is x, will be equal to our f of 0, which is 1, plus, now we're going to go to our first derivative. It's our first derivative, so that's a power of 1, and it would be over a 1 factorial, which is still a 1. But I'm going to put it there just to emphasize. Then we're going to go to our second derivative. That leading coefficient is 9. It's a second derivative, so x is squared. We now have a 2 factorial. Now we're going to go to our third derivative. And our third derivative was 27. We're now going to have an x to the third power because we're our third derivative, 3 factorial. Oh, uh-oh. Come on, sync. Sync. Unfortunately, I'm having to make this on a tablet and it's not behaving quite, there we go, quite how I want it. And now we're on to that fourth derivative where the leading coefficient was 81. We are now x to the fourth power because we're on a fourth derivative, and we are also on a 4 factorial. All right, so this is the thing all messy. We're going to clean it up a little bit because we can simplify those factorials. All right, so 9x squared, 2 factorial is just 1 times 2, which is a 2. Three factorial is 1 times 2 times 3, so that's going to give me a 6. And I'm going to be able to reduce this in just a moment. I think I'll go ahead and just write these first and then reduce. Again, my thing is not erasing, so we'll just have to make do. And on to the last one, we have our 81, x to the fourth, and you have your 4 factorial, which is your 1 times 2 times 3 times 4. But don't forget, your calculator can do your factorials. Let's see, that was under what? Math and probability, so to the right, and number 4. So math, which is the key underneath the green, scroll to the right for probability and go to number 4. So our 4 factorial, whoops, math probability 4 factorial is going to be our 24 that I was saying earlier. And we're going to check to see if can we reduce this at all. All right, final cleaned up answer. Let's see, 9/2 does not reduce. 27 over 6, that is going to reduce. So 27 over 6 is going to give us, let's see, both of these are going to be divisible by 3. So 9/2. And let's check to see, does 81 reduce? 81 over 24. Let's see, math. Let's see, I want... Let's see, does that change? Nope, 27 over 8 is what I got on that in my calculator. So both of those were divisible by 3. All right, and this would be our final cleaned up version for our Maclaurin series of this equation, e to the 3x with a degree of 4. All right, let's do another one just in case you need it. If not, you can just ask the sub to go ahead and pause it that you guys are ready to try your own. But if not, let me do the next one. And by the way, these are going to match up with that 17 through 25, which is your first page, the first couple on this lesson. Okay, notice this time I have trig. Yay, trig. I know you guys love trig. I know you do. So we're going to do the same thing. We're going to evaluate, we're going to derive, we're going to evaluate. Again, these are centered at 0. And notice we are now going to go to the 5th degree. So we're going to go to a 5th derivative. Right, so our original function is cosine. When we evaluate that at 0, it is 1. Then we're going to go to our first derivative. So deriving cosine, we get negative sine. Evaluate that at 0, and we get 0. second derivative. So deriving sine, we get cosine, but there was a negative there, so now we have negative cosine. And that means we'll get a -1 when we evaluate that. Third derivative. We're now going to have a positive sign, right? Because the derivative of cosine is negative sign, but then we had a negative in front of cosine. So that will be a positive sign, and when I evaluate that, I get a 0. Fourth derivative. We're going to be back to cosine. So back to 1. And one more because they said to the fifth. So now we're going to be back to negative sign, which means we'll be back to a 0. Okay, we have all of our leading coefficients now. Let's go ahead and make that that Maclaurin polynomial. So polynomial 5, right? N was 5. Our variable is x. Our first leading coefficient was 1. Plus our first derivative is 0, so I really don't even need to put the 0 there, but I am going to put it there just as a placeholder. So 0 times x to the first power. Then we're on to our second derivative, which will be a -1, so I would erase this, but my thing's not erasing, so I'll just scribble it out. So we have a minus. We are now on to the second derivative, so second power, 2 factorial. Now we're on to our third, which is a 0. And I actually don't need to write all this, but I'm going to clean it up in a moment, so it won't matter. And we're on to our fourth. So the fourth was a leading coefficient of 1. So now we're on the fourth derivative, so 4 factorial. And they wanted us to go all the way to 5, but 5 is actually a 0. And so it's going to go away when I go to clean things up. So my polynomial to the 5th degree, my variable is x. Cleaned up will look like 1. 0 is going to go away. We're going to have minus x squared over 1 times 2, which is 2. My third one's going to go away because of that 0. Plus, we're going to have x to the 4th. We're going to have our 4 factorial, which we just did a moment ago, and was 24. The last term goes away. All right, so that is what you guys are doing with that 17 through 25. Don't forget, when you get to 21, you will have a product. So product rule is going to be required when you're doing your derivatives. I'm so sorry. And on 23, you could rewrite that so that you can use your power rule and then chain rule. All right, so that's 17 through 25. I am not going to be at school today or tomorrow. My dad's in the hospital, so I will just have another lesson for you guys that I'm going to have to pre-record. All right, but again, today, work on that 17 through 25, and then tomorrow we're going to talk about the Taylor polynomials, so when we're centered somewhere other than 0.